All right, we're going to pick up where the 4F video notes left off. In example 2, part B, we see a c minus 1 in two different places in this expression, and so we're going to let u equal c minus 1, and then replace all the c minus 1s with u. And then we get a much simpler looking expression, u squared plus 4u minus 21. This one can be factored as a trinomial. A times c is negative 21, so we need to list factors of negative 21. And we want to find the pair that adds up to positive 4. So we have negative 1 and 21, and the sum is 20. And negative 3 and 7, and there our sum is 4, so that's our pair. Since a is 1, we can skip right to the factors. The firsts in each parentheses are going to be u, because u times u is the first term in the trinomial we're trying to factor. U times u is u squared, so u minus 3, u plus 7. We have one more thing left to do, and that's replace each of those u's with the c minus 1. So c minus 1 minus 3 times c minus 1 plus 7, and then simplify each factor. C minus 4 times c plus 6 is our final result, because our goal here was to write the factors. All right, in C, this one's just a little bit different. If we let u equal n raised to the negative 1 power, that means that u squared would be n to the negative 1 raised to the 2, and when we raise a power to a power, we multiply the exponent, so that's n to the negative 2. In fact, whenever you see one exponent that is twice as big as another, that means that the one that's twice as big can become u squared, and the other u. So u squared plus u minus 20, and there are a times our c is negative 20, so I'm going to list factors of negative 20 until we find a pair that adds up to 1. So we have 1 and negative 1 and 20, and the sum there is 19. Negative 2 and 10, and our sum is 8. Negative 4 and 5, and there our sum is 1. That's the pair that we're looking for. So the two factors are u minus 4 and u plus 5. And now we still have to replace the u, because u was a variable that we introduced. And so each of the u's can be replaced with n to the negative 1. And remember that n to the negative 1 is the same as 1 over n. We typically don't write a final answer in the form with a negative exponent. So we're going to change n to the negative 1 back into 1 over n. All right, some general guidelines for choosing a factoring strategy when faced with, here, factor this completely, and we don't know where to start. So some guidelines for you to follow. Number 1, arrange all of the terms in descending powers of one variable. Then number 2, once you've done that, your first factoring strategy should always be factor out the GCF. It doesn't have to be done first, it will just make your life easier. Then whatever's left after factoring the GCF, we're going to count the terms. If it is two terms, then it could be a squared minus b squared, which is the difference of squares. And remember that that factors into a plus b times a minus b. It could also be the sum of squares, in which case we need to remember that that cannot be factored any further, or it is prime. It could also be the difference or the sum of two cubes, each of which have their unique factoring patterns. If the remaining polynomial has 3 terms, then we're going to factor a trinomial using the AC method. If the remaining polynomial has 4 terms, then we're going to use factor by grouping. Remember that each time you factor, we must check the remaining factors to see if any of those can be factored again. And that factoring may always be checked by multiplying. So now let's put this into practice in example 3a. So first thing we're going to look at is it in descending powers of one variable. So if we look at our first term, you'll notice that x is raised to the 5th power. In the second, x is raised to the 2nd power. That means that the exponents are decreasing as you go, so we're in the proper order. So now we're going to attack this by factoring out the GCF, or greatest common factor, first. So the greatest common factor is 9x squared, and that leaves us with x to the 3rd, y to the 6th, minus 8. What you'll notice is that the remaining factor is 2 terms, and it fits the difference of 2 cubes. So what our first term is the cube of xy squared. Xy squared times xy squared times xy squared is x cubed y to the 6th. What our second term is the cube of is 2. 2 cubed is 8. So now take the first term and square it. Squish the 2 terms together, or multiply them, and then square the second. And now we're ready to put in our operation symbols. So we're going to match the operation symbol, use the opposite one, and then the last was always plus. And if you remember, the remaining trinomial there cannot be factored whenever we factor the difference or sum of cubes. That trinomial is prime, so we don't have to check that for factoring again. You certainly can check it, it just won't factor again. In B, we have something that can be factored as a trinomial. It's in the proper order, first of all. M to the 4th comes first, m to the 2nd next, but there is no GCF to factor out, so in this case we're going to factor it as a trinomial. A times C is -9, and so my factors of -9 that add up to +8 are 9 and -1. Now we can use easy factoring on this one because A is 1. However, the firsts in each parentheses need to be m squared because m squared times m squared is m to the 4th. Now we can just use the factors that we found, m squared plus 9, m squared minus 1. Now let's address m squared plus 9 and see if it factors again. It is 2 terms, but it is the sum of squares, which is prime. That means I'm not going to factor it again, I'm just going to bring it down to my next step. M squared minus 1 is 2 terms. It fits the pattern of difference of squares, which means it's going to factor into m plus 1 times m minus 1. Remember, these factors can be in any order. It's not crucial that they be in the order that I gave them in. In C, this is an ideal one for a u substitution. So let's let u equal, what's in this parentheses, x plus 7. In that case, this polynomial turns into u cubed minus 27, which looks a lot simpler. That's the purpose of u substitution, to make your expression look a little simpler, and so that we know how to approach it when coming to factoring strategies. That's the difference of cubes. That means that it's going to factor into the cube roots of each of those terms in the binomial factor, and then square the first, squish them together, and then square the second. And then I'm going to match the signs, use the opposite sign, and then always plus. There is no additional factoring that can be done because the trinomial from the sum or difference of cubes is always prime. I do have one last thing to do, and that is to replace all of the u's with my x plus 7, which is the variable that we started with. So I want to always end with the same variable that was in the original expression that we were trying to factor. And I've tried to color code that so that it's very clear the substitutions that were made. Now we need to simplify each factor. x plus 7 minus 3 is the same as x plus 4. And this trinomial factor is going to be a little bit more to simplify. X plus 7 squared is x plus 7 times x plus 7, which simplifies to x squared plus 14x plus 49. And then 3 times x plus 7 is 3x plus 21. And then we're going to bring down that last term of 9. We have a little bit of housekeeping to do on that second term. I'm going to combine the like terms. 14x and 3x are 17x. And then 49, 21, and 9 are 79. As it turns out, again, that trinomial does not factor. We can check it, of course, but remember, it came from factoring the difference of cubes, so that trinomial factor will always be prime. In D, we have a polynomial that is not in the correct order. So we need to reorder the terms so that the a to the 5th term comes first. Remember to bring the signs on the left of each with them. So that means that the 81a is positive and the a to the 5th is negative. Since the lead term is negative, I'll factor out a negative GCF. So factor out negative a. That leaves us with a to the 4th minus 81. Be very careful when you're factoring out a negative. That negative 81 is crucial to doing the rest of the factoring. A to the 4th minus 81 fits the pattern of the difference of squares. So it will factor into a squared plus 9 times a squared minus 9. A squared plus 9 is prime, so it can't be factored again. It's the sum of squares. A squared minus 9 again fits the difference of squares factoring pattern, so it will factor into a plus 3 times a minus 3. At this point, none of the factors can be factored again. In E, we have 4 terms, but before we begin, we need to check the order x to the 5th, x to the 3rd, x squared, and no x's in the final term. That means it's already in the proper order. However, we need to factor the GCF first. So the GCF is 2. Now you might say, hey, 2, no big deal. I can factor that later. It will make our lives easier if we factor it first. So make sure that we factor 2 from every single one of the 4 terms. And if the remaining polynomial has 4 terms, that means it must be factored by grouping. So I'm going to open up a bracket here for this factor and factor the first group. X cubed is a common factor, leaving x squared plus 9. And for the second group, bring down that minus sign in between the two groups. That means we're factoring out the negative GCF, or negative 8, and that leaves us also with x squared plus 9. So that means the two factors from factor by grouping are x squared plus 9 and x cubed minus 8. 2, the GCF cannot be factored again. X squared plus 9 is the sum of squares, cannot be factored again. X cubed minus 8 is the difference of cubes, which will factor to x minus 2 times x squared plus 2x plus 4. And now we are done. We have all the prime factors. In F, we have a trinomial. The exponents are descending, 7 to 4 to 1, but there is a GCF, so I'll factor out the GCF first. So we have u times u to the 6th power plus 28u to the 3rd power plus 27. What you'll notice is the remaining terms inside the parentheses form a trinomial. And a is 1, which means that we have an easier factoring to do. The first in each of the parentheses must be u cubed. The first term's u cubed times u cubed gives us the u to the 6th first term in what we're trying to factor. And the factors of 27 that add to 28. So the factors of 27 that add to 28 are positive 27 and positive 1. Each of these factors fits the pattern of the sum of cubes. which means the binomial factor of the first is u plus 3, and the trinomial factor is u squared minus 3u plus 9. The binomial factor of u cubed plus 1 is u plus 1, and the trinomial factor is u squared minus u plus 1. Remember, the trinomial factors of sum or difference of cubes cannot be factored again, so now we have our final result. I almost thought that was a u substitution, but it's not. U was the original variable in the trinomial to be factored, so we are done. In G, we have a to the 6th minus b to the 6th. That can be factored using with the difference of squares as a starting point. So using the difference of squares, our firsts must be a cubed, since a cubed times a cubed is b cubed, and then our seconds in each parentheses are b cubed and minus b cubed. A cubed plus b cubed times a cubed minus b cubed gives us a to the 6th minus b to the 6th. Each of these can be factored again. A cubed plus b cubed is the sum of cubes. That factors into a plus b times a squared minus ab plus b squared. And a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. This can be factored using the difference of squares first, or the difference of cubes first, but it will be much, much, much harder, and by harder I mean impossible, given the factoring that you have been exposed to. It's much, much trickier to do it the other way, and so I recommend you always start with the difference of squares if you have a choice. In example 4, we are finding the solution set, which means we're solving, which means that we are finding the value or values of the variable that make an equation true. It's important to realize that when asked to factor, you're not being asked to solve, nor is it appropriate to solve, since there is no equation to solve. So in example 4, we need to have a 0 on one side of the equation. So I'm going to subtract 4m cubed, subtract 9m squared, and leave the m to the 4th and 36m on the left side of the equation. It is important to write equals 0. Notice that when I moved the terms, I put them in descending powers. This is 4 terms, so we're looking for a GCF, and I can find a GCF first of m. That leaves us with m cubed minus 4m squared minus 9m plus 36. The remaining polynomial in the parentheses is 4 terms, so I'm going to use factor by grouping. The first group has a common factor of m squared. That leaves us with m minus 4. Bring down the minus sign in between the two groups. There's a 9 that's a common factor, so we're going to factor out negative 9, and that leaves us with also m minus 4. And so that means the 3 factors are m, m minus 4, and m squared minus 9. But wait, there's more factoring to be done. M squared minus 9 factors to m plus 3 times m minus 3. And now we can set all of the factors equal to 0. If m equals 0, then m is 0. If m minus 4 is equal to 0, m is 4. If m plus 3 is equal to 0, m is negative 3. And if m minus 3 is equal to 0, then m is positive 3. And we finally have a solution set. You must show the factors, but it's okay if you set them equal to 0 in your head and solve as long as we're showing where they came from, which is the factors. In B, we have an equation to solve. Before we start moving terms, we must multiply on both sides. So you don't want to subtract until you multiply. Think order of operations. So 3x squared minus 5x is equal to 2x minus 4. Now let's subtract. Subtract 2x from both sides and add 4 to both sides. And now we have a trinomial equal to 0. So the trinomial has no GCFs to factor. So I'm just going to do the AC method. And our a times c is 12. Factors of 12 that add to negative 7 are negative 3 and negative 4. Since a is not 1, we must split the middle term, 3x squared minus 3x minus 4x plus 4 equal to 0. Factor by grouping, 3x times x minus 1 minus 4 times x minus 1 equals 0. So our two factors are x minus 1 and 3x minus 4 that multiply to give a result of 0. If x minus 1 is equal to 0, or if 3x minus 4 is equal to 0, we will get solutions of 1 and 4/3 in our solution set. Here's one for you to try. Pause the video while you try this one on your own. Here is the solution for C, and that's it for the lesson.